Welcome back to section 4 of chapter 5. In this section, we are going to see another way of solving quadratic equations which will work even if we're not able to factor them, because there are some quadratic equations that factoring is either very, very difficult or just downright impossible. And so this method, which will actually lead us into the next topic, is called completing the square. And so we're going to, basically the idea of completing the square is we're going to get it so that we have something squared equals a number, and we can take the square root of both sides. So, our learning targets for the day: I can solve quadratic equations by completing the square, and I can write quadratic equations in vertex form. We've seen how to go from vertex form to standard form. Now this will let us go from standard form back to vertex form. Now with the solving, we will learn other methods of solving where we won't need to complete the square. However, to write it in vertex form, you will have to complete the square. There's no way around that. So this is something that you definitely need to know. So first of all, we're going to look at solving using square roots. If we have x squared equals 9, what squared equals 9? Right, 3 squared equals 9. What else squared equals 9? Negative 3 squared also equals 9, because negative times negative is positive. Now I know a lot of people put this in their calculator, they just go negative 3 squared, and they'll get negative 9, because your calculator does not put the parentheses. It just goes 3 squared and then it adds a negative to it. So when you are doing stuff in your calculator, including on the previous topics, make sure that you have stuff in parentheses when you square it. So x squared equals 9 means that we could have 3 squared, or we could have negative 3 squared, which means we have two possible answers here. X could equal 3, or x could equal negative 3. And being that it's the same number, we could actually rewrite it as x equals plus or minus 3. This means exactly the same thing as this. So there are two ways of writing that. And sometimes this way will definitely come in handy, and we'll see that in a couple of examples. So, and this is illuminated by the square root property, which says if a squared equals b, then a equals plus or minus the square root of b. Now, the square root of 9 is still 3. It is not plus or minus 3. The only time we get plus or minus is when we have x squared equals a number and we square root both sides. So how are we going to use this? Well, if we have an equation, x minus 2 squared equals 16, we can square root both sides because we have something squared equals 16, which means what squared equals 16? Either 4 or negative 4. So we could square root, and so x minus 2 equals plus or minus root 16, which would be plus or minus 4. So x minus 2 equals 4, or x minus 2 equals negative 4. To solve for x, we would just add 2. And so when we add 2, 4 plus 2 equals 6, and negative 4 plus 2 equals negative 2. Notice here they did not come out to be the exact same number with a plus or minus. That usually won't happen. It'll usually be two different numbers. Just like when we were doing absolute values. We had the absolute value of something equals a number. Well, that means that the inside could equal positive or negative. So if this wasn't squared, if it was absolute value, it would just be plus or minus 16. We now have the square root of 16. Other than that, it is the same. And so x equals 6 or x equals negative 2. Well, there's another type. Here we have x plus 3 squared equals 7. So we can square root both sides. So you get x plus 3 equals plus or minus root 7. You might be thinking, wait a second. The square root of 16 was 4. That was easy. The square root of 7 is 2 point something something something. No, the square root of 7 is not 2 point something something something. The square root of 7 is just the square root of 7. Leave it as it is. This problem actually turns out to be a little bit easier, because when you subtract 3 now, you're just going to get plus or minus root 7 minus 3, or negative 3 plus or minus root 7. That's the answer. You don't even have to combine them. So x equals negative 3 plus or minus root 7. This one we would not have been able to solve by factoring. This one we could have. We could have multiplied this out and solved it by factoring. But this one, not so much. And so these are the two basic solving using square root type questions. There's a type where it works out nice, and the type that it doesn't work out nice, and we end up with a square root in the answer. And so let's try one. We have x plus 2 squared equals 36. Go ahead, pause, follow the steps, see if you can solve this by using square roots, and then push play when you're ready to come back. How'd you do? Was this one pretty easy? I hope so, because this is set up to work out nicely. So first step, square root both sides. X plus 2 equals plus or minus root 36, which would be plus or minus 6. Then we just need to subtract 2. 6 minus 2 is 4. Negative 6 minus 2 is negative 8. Did you get it? If so, great. If not, can you see where you made a mistake? Was it in this step here where you have to subtract from the negative and positive? And so that was using square roots. That's if it's already in the form to solve. But sometimes it's not. We can solve using square roots even in standard form, and that uses a process called completing the square. Now, I explain completing the square a bit differently than the book does, because the book uses a few equations and it goes in a very linear fashion. I find it's a lot easier to do it this way, but we kind of do two steps at the same time, back and forth. Usually we don't go back up in our work, but in this case we will. So this is one that you want to pay a bit of attention to, because trying to look at something that's already been done is very difficult there. So let's start out with an equation. X squared plus 8 equals 6x. The first thing we need to do in completing the square is we need the x's, that would be the x squared and the x, on one side, and the constants, just the numbers, on the other side. So we need to subtract the 6x and subtract the 8. So you have x squared minus 6x, and then equals negative 8. Notice I left a little space here. We're going to use this space. And so now when we complete the square, we have x squared by itself, with the rest of the x's over here. We are going to have parentheses. X squared, well, what squared equals x squared? X. So we have x plus or minus something, we don't know what that is yet, squared will equal something. Now we're going to work on filling this in. The first thing we're going to do is we're going to take this number right here, this negative 6, and we're going to divide it by 2 and put it right down here. Negative 6 divided by 2 is negative 3. So we have x minus 3 squared. Okay, well, if we multiply this out, which is not x squared minus 9 or x squared plus 9, but it's x squared minus 6x and then plus 9, because we have the negative 3 times negative 3. We need a plus 9 up here in order to make these true. So we're going to take whatever this number is, in this case negative 3, and we're going to square it and add it up here. So plus 9. Now, can I go around adding 9 to an equation wherever I feel like it, all willy-nilly like? No, I can't. If I add 9 here, what else do I have to do? I have to add 9 over onto the other side. So negative 8 plus 9 is 1. That's completing the square. This is the step where we do it 2 steps kind of at the same time, back and forth. We take this number, divide by 2 to put it there, then we square this number and add it. It will always be added, because when we square it, it will be positive. Add it to the other side, and then we can combine these two to go down here. Now it's set up just like the last ones. We can take the square root of both sides. So the square root of x minus 3 is just x minus 3 equals plus or minus the square root of 1, and the square root of 1 is just 1. Then add 3. 1 plus 3 is 4. Negative 1 plus 3 is 2. So here x could equal 4 or 2. And so that, again, is the completing the square step. It is a process that's kind of weird. We're going to see it a few more times. So let's go with x squared minus 4x equals negative 1. Here it's already set up with the x's on one side and the constants on the other. And so we just need a space. And we need our complete the square step. The x times some, or plus or minus something squared equals a number. Now we're going to take this number and divide by 2. Negative 4 divided by 2 is negative 2. Then we're going to take that number and square it. And so we get plus 4. If we add 4 there, we have to add 4 to the other side. Negative 1 plus 4 is 3. Now we can square root both sides. So we get x minus 2 equals plus or minus the square root of 3, which is just plus or minus the square root of 3. Add 2. X equals 2 plus or minus the square root of 3. And we generally put that number in front of the plus or minus, as opposed to plus or minus root 3 plus 2. That just seems weird. So we put it in front. All right, so that was another completing the square. Notice same thing. Now they do get harder than this. There's a couple things that I can do to make this harder. First of all, I can put a number right here. I'm going to add a coefficient. That's one thing I can do to make it harder. The second, this division might not be a nice division. What if this was negative 5? Well, that'd be negative 2.5, which makes this a decimal or a fraction. It happens. But that's really the only stuff we can do to make it harder, is make the numbers a little bit harder to deal with. So with this one, we have 3x squared plus 6x equals 1. We don't want 3x squared. We want x squared. X squared. We just want x squared. So to get rid of the 3, we need to divide everything by 3. And when we do that, we'll get x squared plus 2x equals 1/3. When I say divide everything by 3, I mean everything. So it equals 1/3. Right, now this is set up where we can do the complete the square step. So we get parentheses with x squared equals something. And now we need to take this number and divide by 2. So you get plus 1, square it. Well, 1 squared is just 1, so plus 1 on the other side. 1/3 plus 1 is 4/3. Now we can take the square root of both sides. So x plus 1 will equal plus or minus the square root of 4/3. Well, square root of 4/3 is not a pleasant number. So let's split up into top and bottom. We have square root of 4 or square root of 3. Square root of 4 is just 2. So we have plus or minus 2 over root 3. Well, if you remember back to chapter 1, we don't like having square roots in the denominator. So to get rid of that, we'd multiply by root 3 over root 3 to give us plus or minus 2 root 3 over 3. And now we can finish to get x equals by just subtracting 1. So we'll have negative 1 plus or minus 2 root 3 over 3 equals x. So this problem was, notice, a lot more complicated, but really the completing the square step was right here. Then we square rooted. The thing that made this one more complicated was just because we had that square root in the denominator. That was all it was. We've dealt with that before. So don't let that kind of stuff trip you up. This part was exactly the same, and this part was the same. And that's just hanging on. It's basically negative 1 plus or minus the square root of 4/3. We just wanted to simplify. All right, so try this one. It won't be as hard as that last one. 2x squared minus 20x equals 8. Notice it's already set up with x's on one side and constants on the other, but you have that 2. So go ahead and pause it, deal with the question, and then push play when you're ready to come back. How'd you do it? Did you do it? If you didn't do it, go pause it and go back and do it. All right, did you do it now? No, you're just waiting for me to pause it, go back and do it. Participate in your own education. Push play when you're ready. All right, did you do it this time? I certainly hope so. All right, first step, divide by 2 to get x squared minus 10x equals 4. Put the space, because now we're ready to do the completing the square step. We have x plus or minus something squared. Well, that something, negative 10 divided by 2 to get negative 5. Square it to get plus 25, and plus 25 on the other side. 4 plus 25 is 29. Now we're ready to solve. Square root both sides. X minus 5 equals plus or minus square root 29. Add 5. X equals 5 plus or minus square root of 29. That's it. Solved completing the square. So notice it doesn't have to be as hard as all this. All right, and then last deal, writing it in vertex form. It's actually the exact same as just completing the square. So if we have an equation in standard form, g of x equals x squared minus 10x plus 11, we're going to have to move the 11 over because we want just the x's on one side. So we're going to subtract the 11. And notice I left a space. In this case, the sides of the equal sign have been switched. Doesn't matter. You can flip it around if you want. You can go x squared minus 10x equals g of x minus 11. But the x squared minus 10x, that's ready for completing the square. So we'll have x plus or minus something squared equals the g of x will hang around. The 11 will change though. Same thing. Negative 10 divided by 2 is negative 5. And square it to get plus 25. If we add it there, we have to add it to the other side, plus 25. Negative 11 plus 25 is 14. And then we just need to subtract the 14 over because we don't want g of x plus 14. We want g of x. So subtract the 14 over. We get g of x equals x minus 5 squared minus 14. That's vertex form. This would be a parabola. The vertex would be at 5, negative 14. What if we have that coefficient there? Same basic idea. We need to divide by 3. Well, h of x divided by 3 is just h of x divided by 3. The others we can. The 53 will be a 53 over 3 because that doesn't divide nicely. But these two do. And so, from here, it's just like this one. We'll subtract the 53 over, leaving a space. And now we can complete the square because we have x squared by itself. So we'll have x something squared. That would be a minus 4 because negative 8 divided by 2 is negative 4. Which means we have to square this. Negative 4 squared is 16. So plus 16 there. And we're going to add 16 over here too. But we have to add it to 53 thirds. Negative 53 thirds. So instead of 16, let's change it into thirds. 16 is 48 thirds. So we're adding 48 thirds. Negative 53 thirds plus 48 thirds is negative 5 thirds. And now we can move that negative 5 thirds back, so we can add it to the other side. H of x over 3 equals x minus 4 squared plus 5 thirds. And then multiply by 3. That's going to get rid of the thirds here, and it's just going to put that 3 out here. It's going to put that a value, that vertical stretch or compression. So h of x equals 3 times x minus 4 squared plus 5. This is a parabola that has a stretch of 3, and the vertex is at 4, 5. So this would be writing in vertex form. Notice it's the same process, completing the square. Hopefully we've seen enough completing the squares. We see this process. We're going to take this, divide by 2, square it, put it on both sides, and then we go on from there. So completing the square, I think it's kind of fun personally, but I'm kind of messed up in the head, people say. But I do enjoy it. I think it's a fun little process, and it's a cool way of solving these equations. But it also allows us to write things in vertex form, and again, that is the only way that we can do that. So it is important to be able to complete the square. So anyway, have fun completing the square. I'll see you next time. Until then, happy mathing.